S1 and S2, and the gap between them is 2 lambda. And there is a line on this one, there is a detector. On this there is a detector, and on this one, this detector is moving. The question asks you, what is the smallest distance from S2? What is the smallest distance from S2 minima will occur? Okay, wavelength is lambda. Okay, and this distance is given anyhow. So what is the smallest distance from S2 where the minima will occur? The first question is, at S2's position, what is occurring? It's a maxima or minima? The path difference from S1, how much distance the ray will travel to reach over here? 2 lambda. And how much is the distance traveled by the ray which is starting from S2 itself? 0. So what is the path distance? 2 lambda. Now 2 lambda corresponds to maxima or minima? Maxima. Which maxima? Second maxima. So here second maxima is come. So as you move in this side, what's going to come? Okay. Let's see. If suppose I go to infinity from here, what's going to come at infinity? At infinity I will be getting 0 as max. Then comes first minima. Then comes first maxima. Then comes second minima. Then comes second maxima. So what we are going to get here? Second minima. And for second minima, how much should be the path difference? For first minima, lambda by 2. For second one, 3 lambda by 2. Okay. So the wave coming from S2 and wave coming from S1, their path difference should be equal to what? 3 lambda by 2. Okay. So let's see. I am taking this distance as x. And this point is P. Okay. So delta x is S1P minus S2. The question is, what is S1P? S1P is 2 lambda whole square plus x square square. Why? Because that's the hypotenuse of this. So 2 lambda whole square plus x square. Square is S1P. What is S2P? S2P is x1 minus x. That's equal to what? 3 lambda by 2. How to solve it? Bring x this side. 3 lambda by 2 plus x equal to 4 lambda square plus x square square. Now square this both sides. Square it. See what's coming. So when you are squaring on both sides, this comes 9 lambda square by 4 plus x square plus 2 into 3 lambda by 2 into x. What are we using? Using a square plus b square plus 2a. And on the right hand side, 4 lambda square plus x square. Now this x square and this x square gets cancelled. Now what we have here? This 2 and this 2 also get cancelled. So 9 lambda square by 4 lambda square is 8. So 3 lambda x equal to 4 lambda square minus 9 lambda square by 4. This is 16 lambda square minus 9 lambda square. That means 7 lambda square by 4 equal to 3 lambda x. Lambda is gone. X value is 7 lambda by 12. Okay. So at this position you are going to get the second minima. Alright. Let's see one more question now. See how this question is. There are two sources, S1 and S2, and the gap between them is B. Okay, exactly from the middle, we are having this line, and there is a screen over here. Gap is exactly at this point, and another gap is there, which is somewhere up. So that means from these two sources, you are making another two sources, and these two sources are going to have interference on this screen. This you can say is S3 and this you can say is S4. Okay, and the separation between them is given to you is Z. This distance is capital D and this distance is also capital D. Alright, now what the question is asking, find ratio of I maximum to I minimum when Z is lambda D by 2D, when lambda D by D and lambda D by 4. That means three questions are being asked from us. Okay, and we have to find the ratio of I maximum to I minimum. So what we have to do? Now see, I am solving it. If S1 I assume this intensity is I and S2's intensity is also I, and this is the bisector of that, then what I am going to get because of these two? I am going to get here maxima. Why? Because they have no path difference at this position. So what we are going to get over here? Maximum. What is the intensity? 4I. Okay, let's talk about this point now. S3. The first thing we are taking lambda D by 2, and it's given to you that D is very large, lambda is very small. Okay, so Z value is lambda D by 2. Now look at this value actually. This is actually beta by 2. Okay, if this is maxima, at beta by 2, what I am going to get? Minima. So this intensity here will be 0. Okay, so if this is 4I and this is 0, and here I am going to calculate I maximum, what will be I maximum? I max is what? It is root I1 plus root I2 whole square. And what is I minimum? Root I1 minus root I2 whole square. Now I know that I1 is 4I but I2 is 0. So here also I am going to give 4I. This is 0. Here also 4I. Here 0. What will be the ratio? 4I plus 0 square. 4I minus 0 square. What is going to come? 1. Okay, answer will be 1 because numerator and denominator both are same. So in this case, the ratio of I maximum to I minimum is going to come 1. Let's see the second case then. Now it's lambda D by D. Now lambda D by D means is 1 fringe width. That means beta. If Z is equal to lambda D by D means beta. Here I am going to get 4I. So if this is equal to 1 fringe, that means here also maximum. That means here intensity is also 4I. Then in this case, what is I maximum? I maximum is root I1 plus root I2 whole square. That means root 4I plus root 4I whole square. What about I minimum? Root I1 minus root I2 whole square. Then the ratio of that. Now you see that this is 0. Denominator has become 0. So whatever this is, by 0 is infinity. So B option's answer is infinite, that means undefined. Now let's go for the third one. What is third now? When the gap is lambda D by 4D. Okay, this is lambda D by 4D. So what will be S3? That we have to check now. Lambda D by 4D, this set value. See, if suppose I consider this is central maxima and this is the value of Y. Normally we used to calculate this as Y. Okay, and Y we used to write as delta X capital D by D. If you remember, recollect it. So actually here Z is equal to delta X D by D. And how much this is given to us? This value. Lambda D by 4D. So this and this gets cancelled. What we are getting is delta X. Lambda by 4. So if delta X is lambda by 4, what is delta phi? delta phi is 2 pi by lambda into delta x. That means 2 pi by lambda into lambda by 4. That means pi by 2. That means at this point, how much is the phase difference? Pi by 2 between the two waves which are coming from S1 and S2. So first thing is we are going to find what is intensity here. Okay. How to find intensity? We have the formula IR equal to 4I cos square pi by 2. Okay. So this is 4I. Pi is given to you what? Pi by 2. So cos square pi by 2 by 2. That means pi by 4. Cos pi by 4 value 1 by root 2. Let's put it 4I cos pi by 4 value 1 by root 2 whole square because of square. So 4I by 2, that means 2I. So here intensity we are getting is what? 2I now. Then we have to find again I maximum by I minimum ratio. What is I maximum in this case? I maximum again root I1 plus root I2 whole square. Root 4I plus root 2I whole square. I minimum root I1. What is root I1? 4I minus root 2I whole square. Let's see what's coming here. A square plus B square plus 2AB. Now A square means 4I. B square means 2I plus 2 root over I1 I2. That means root over